Okay, so what we saw is the WPA handshake. It works. It makes sure that people with the Wi-Fi password can connect, but people with the wrong Wi-Fi password cannot. But there's one thing I don't like about it, and that is the fact that it's kind of slow. If you look at this naive, intuitive handshake, there are a lot of messages that the client and the access point have to send back and forth. So for example, if I count the number of back and forth messages that have to be sent, there's 1, 2, 3, 4, 5, 6, 7 messages that have to be exchanged back and forth for this handshake to succeed. That's kind of a lot. Imagine every time you connect to the Wi-Fi network, you have to wait for 7 packets to go back and forth across the network before your connection can be established. So what we'll now do is try and optimize this so that we get the same behavior. Both sides derive this purple key if they have the Wi-Fi password. We exchange MACs to make sure that nothing was tampered with, and we send the GTK for group communications. All of these same goals get achieved, but with fewer back and forth packets being sent. So we'll do a little bit of optimization. The resulting handshake is a little less intuitive because we'll be squishing some of the steps together, but in reality, it's going to be faster than what we have here. So this is the optimized version of the exact same handshake that we did. So there's still an authentication request. That doesn't change. Both sides still independently offline derive the blue PSK from the Wi-Fi password. This also hasn't changed. And the access point generates a random number, sends it to the client. This also hasn't changed. So everything is the same so far. But here comes the first change. At this point, if you look at the client, they have all the information they need to derive the purple key. So in the naive version, they would exchange nonces first and then derive this key in purple. But this client says, you know what? I have everything I need. I have this key in blue because I derived it. I have both nonces because I know my own nonce, and I received the other nonce from the access point, and I know both of our MAC addresses. So because I know everything I need to know to generate this key in purple, I'm just going to generate that key right now because I have all the information I need. So this is one of the optimizations we're making. The client is generating this key in purple as soon as they are able to. So why is that useful? Because if they generate this key in purple now, when they send the S nonce, they can also send the MAC to the access point. So this is the point at which we took 2 messages and squished them into one. In the naive version, the client sent the nonce here, and then later, after the keys were derived, it would send the MAC code to make sure that nothing was tampered with. Here, the client is somewhat rearranging the order in which it's doing things, deriving the key in purple first, and then sending both the nonce and the MAC code in a single packet. So that removes one of the packets that we had to send. So that's a good optimization. Now at this point, the access point has everything it needs to derive the purple key. It knows the key in blue from the derivation from the Wi-Fi password. It knows both of the nonces. It received one from the client, and it knows its own nonce. And it knows both of the MAC addresses. So now the access point is able to derive the key in purple. And once again, we'll do another optimization. At this point, the access point will send the MAC code to make sure that the key in purple was derived correctly, but it's also going to send the group key at the same time. So once again, we've taken what was previously 2 separate messages and squished them into one to get better performance. And finally, the client sends the acknowledgement to say that the GTK was properly received. So if you remember the original handshake, including the authentication request, there were 7 back and forth messages, and now we've decreased that to 1, 2, 3, 4, 5. So that's good. We've taken a 7-way handshake and turned it into a 5-way handshake. Sometimes people call it a 4-way handshake if they ignore the authentication request step, but this is good. It makes the handshake faster, although intuitively, all of the things we're doing have not changed at all.